right, so this is a chemical we haven't used before. And if you're trying to figure out the shape of the bonds or even the shape of the molecule, the place we have to start with all of these is the electron dot formula. Okay, so to do an electron dot formula, we have to start with the periodic table. You know, everything starts with the periodic table, right? Okay, so here's nitrogen, and nitrogen is in the second row. So that's the second primary level is its valence level. That's where all the actions taking place between electrons that form bonds.
And you can tell that by the rows?
Because it's in the second row, that's its valence level. The second primary energy level is its valence level. And in its valence level, we can tell how many electrons there are because this whole section over here is the p sublevel region. We have 1, 2, 3 electrons in that p sublevel region. And over here we have 2 electrons in the s sublevel region. And the s and p together make up the valence electrons. So we have a total of 5 electrons on that nitrogen. So let's write an electron dot formula for nitrogen. Okay, and we're going to put 1 on each of the 4 sides, and you work until you run out of electrons. Okay, so here's 1, 2, 3, 4. Well, now we need to go back and pair 1 up, and it doesn't matter which side you start on. Okay, I'm going to put it right here. Okay, and it doesn't matter. Yours is fine. You got 1 at the top. It doesn't matter where you pair them up. All right, so then we want to also do the same thing with oxygen. Oxygen's right next to it. Okay, so instead of 5, it's got to have how many electrons? 6. Okay, so we put 6 dots. 1, 2, 3, 4, 5, 6. Okay, and then we've also got a chlorine. Okay, and you have to be real careful about your capital and little letters. Some students aren't very good about differentiating between the two, but if it's not clear, it's not there. Okay, because you have to know that that's supposed to be Cl. Okay, and not a capital I. So you have to make sure you're writing your I's differently than your little L's. Okay, but how many electrons are going to put around a chlorine then? It's right here. 7. Because we count them up, you got 2 in S, and then 5 in P, and that's 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Okay. Now here comes the tricky part, and this is kind of process of elimination. So I want to switch from doing it in a permanent marker to a pencil, because I might have to erase. Okay. Let's see. Here's a pencil right here. You have a pencil on you?
No, I have a pen.
Here you go. I'll give you a pencil there, and I'll find another pencil here. Okay. And we're going to try to figure out how to get all 3 of these atoms so that their valence level is full of electrons, and a full valence level is 8. Okay, at least with larger atoms. Hydrogen only wants 2, but most of the atoms, larger atoms, after you get past the first row, get that out of the way. After you get past the first row on the periodic table and the first couple elements, the next one, everything wants 8. Or actually, I guess through about boron or carbon, you want 8. Okay. So we're going to try to share electrons until we get an arrangement that makes sense. Okay. Now, in this class, what makes sense may not be the actual real version. Okay. That's okay, because if I'm asking you just to do this, you don't have to give me what it's supposed to be. You have to give me what makes sense at your level. Okay. So let's start sharing electrons. You go ahead and start trying to figure out how to share electrons so that all of these atoms have all the electrons they want. You know what? I'm just thinking here. Can we do that? Yeah, we can do that. That's right. We can. Good. You got it. First time out. First time out of the gate. And you said you were having trouble with this. So if you're watching this on video, you're not seeing hers. I wrote mine a little bit differently. But basically what she did was she made a double bond between the nitrogen and the oxygen and a single bond to the chlorine. Okay. Most of the time when I'm doing this in class, I already have the elements arranged so it's easier to see. But there's nothing wrong with stretching it out there as long as you're doing what you're supposed to do. All right, now we're ready to write a Lewis dot formula. We squeeze the electron sets that are shared in between the atomic symbols. So between the chlorine and the nitrogen, I need to squeeze 1 set or pair of electrons. So I'm going to put 2 electrons between the chlorine and the nitrogen. Okay. And how many electrons do I squeeze between the oxygen and the nitrogen?
2.
Well, 2 sets or 4.
Okay.
Is that what you meant?
Oh, because they share these 2.
Well,
right
between
here.
nitrogen and oxygen, there's 1, 2, 3, 4 electrons being shared between the nitrogen and oxygen. Okay, so we got to put 4 in there. All right, and so we're going to put our oxygen over here. Now we got to go back and find all our lone pairs and put those on all the atoms. So chlorine has 1, 2, 3 lone pairs, a total of 6 electrons. Okay. Nitrogen just has 1 lone pair, and oxygen has 2 lone pairs. Okay, and that's the Lewis dot formula.
Does it matter where you put them on the oxygen?
Not really, not at this point in time. Okay, later on, maybe in a college class, the professor might expect you to arrange this a little bit differently, but in this class right now, this is perfectly okay. All right. So now we're ready to do the Lewis formula, where we replace any shared pairs of electrons with a single line. So you can do that, right? All right, go ahead and do that, and I'll follow up behind you, and we'll see how you did. Good. All right, so far you're doing just great. You just probably need a little reinforcement here. You knew the stuff, right? Okay, so now we got to figure out the shapes. This is the three-dimensional stuff that may be a little more, challenging. And some students do real well with this because, we got somebody that sits back over here that just could see this stuff in his head. Athletes tend to kind of see things in their head sometimes, and people have taken art can kind of see it in their head a little bit. But if you haven't done all those things, what I do is give you kind of a simplified set of tools to make it happen anyway. Okay? So what we want to do is to count the sets of electrons. We go back to this Lewis. Now this is the Lewis dot formula. You need to know the difference between the names. Lewis dot formula. Okay, and this down here is the Lewis formula. And up here, when we first wrote just the symbols with the dots, that was our electron dot formula. But now that we put it all together with the circles, this is now the sharing arrangement. Okay? All right. So what we want to do is count the sets of electrons around the central atom. Now, on a test or homework, you don't have to circle any dots or anything. I'm just going to circle it here so you can see what I'm talking about. Okay?
How do you know which one's the central one?
Well, just look. What's everything tied to?
The nitrogen?
Yeah. It's not as hard as all that, really.
Yeah.
Okay? It's just
I
the one that
realized
so the central atom is either the one that everything's tied to or the one you're interested in at the time. So we might be interested in what's going on with chlorine. But knowing what's going on with chlorine doesn't tell us the shape of the molecule. The shape of the molecule is going to be determined in this case by the nitrogen. Now, when you get in, are you thinking about a nursing career or a doctor or something
I've thought
like that?
about it before, yeah. Maybe something in, like, personal training and stuff.
Okay, so you're going to have to take a lot of organic chemistry. I have a daughter who's a physical therapist.
Oh, really?
Her husband's a physical therapist. Okay?
That's really cool.
Yeah. She got her doctorate from a college down in Florida. She worked up in Charlotte. That's my grandchild over there on the wall over there. Got another one on the way. Okay? Well, and she'll tell you got to take a lot of organic chemistry. Got another daughter who's a pharmacist. A lot of organic chemistry. Okay? So this is all the beginnings of understanding how the three-dimensional arrangement of our atoms come together to build all these really, really big molecules we call proteins. And everything in your body except the bones and the water is pretty much proteins. Your hair, your skin, your eyes, fingernails is all proteins. Okay? All right. So what we want to do here is to, in this case anyway, is just count the sets of electrons around the central atom. This is how we're going to figure out the shape of the molecule. I'm going to do that first, then we'll come back and figure out what the bonds actually look like, okay? So we're going to do two different things here. So I want the sets of electrons are one of two things. They're either lone pairs. Well, on this nitrogen, I have one lone pair. That's a set. Another thing that makes up a set is all the electrons shared between two atoms. Okay? So this is all the electrons shared between these two atoms, but in this case I have 4 electrons shared between those two atoms. So that's a set, and that's a set. That makes sense? So what I want then is a three-dimensional shape that's going to get those 3 sets as far apart as I can get them in three-dimensional space.
So all of these are lone pairs right here, or just this?
No, the lone pair is something that it's a pair of electrons, of electron dots, that aren't bonded or shared between anything.
Okay.
So this is a lone pair. These are lone pairs here. These 3 are lone pairs here. But in this case, we only care about this one because only that central atom is going to determine how our shape of our molecule comes out.
Okay.
Okay? All right. So what we want to do then is to put that central atom, or later on when you get to more complex stuff, not in this class so much, but later in other classes, Maybe you'll take AP chemistry, or maybe you take organic chemistry or something, or maybe you take these college classes. You'll need to know what's the atom I'm interested in here, okay? Because in a really big molecule, you got a lot of these things going on at one time. All right, so we're going to take just the nitrogen, and we're going to arrange those three sets as far apart as I can get them. Now, if you kind of close your mind and eyes and think about it, you can probably figure out what geometry is going to get those three sets as far apart as you can get them. Mm-hmm. What do you see?
Like a...
There you go. How many, if I had, you're doing it, she's doing it with her fingers here. So they're as far apart as I can get them. I can hardly bend my fingers around. What degree angle do I have between those?
120.
120. See, all that math stuff you took, geometry, is paying off here. 120 degrees apart. Now, I don't expect it to be perfectly 120, but I certainly don't want to see a 90.
Yeah.
I don't want to see 180. So it's got to be somewhere between there, right? Mm-hmm. Okay. Again, I don't expect you to be an artist, but something reasonable. So now I just need to put those sets of electrons around that central atom. And in this shape here, it doesn't matter on which of those arms you put it.
Okay.
Okay? So just put your dots on there somewhere. Okay?
So on one of them I need 4.
Okay. All right. So I'm repeating what she's doing. She's putting 4 down here.
And on the other ones I need 2.
2 on the other 2. That's right. Good. Okay. So now that's called trigonal planar. Because if you think about it, 120 degrees apart, that would sit down flat, wouldn't it? Mm-hmm. Okay? So that's, we're going to call it, the name of this then, the geometry name, is called trigonal planar.
Is anything with 3 going to be trigonal?
Pretty much. When we had trigonal pyramidal, that's another shape, but that's kind of like almost a tripod sort of thing, okay? Where this is trigonal, it's flat, okay? A little bit different. But yeah, we use trigonal to indicate there are 3 something. So you've got 3 shapes that are trigonal. You've got trigonal planar, trigonal pyramidal, and trigonal bipyramidal.
And
we've done all those, right? Okay. Now, and there's illustrations of that in the unit handout. But I'll be glad to go over those if you want to. In fact, we did a trigonal bipyramidal yesterday.
Yeah, I remember.
Okay. All right, and then the name of the kind of drawing we're doing here is called an electron pair shape. And we call it that because nothing but electron pairs around the outside. Okay?
Okay.
Okay.
So now it's like all one name, like that's all?
Yep, this is like the first name, this is the last name.
Okay.
Okay? All right, so what we want to do now is to go and draw this whole shape over again. Now you want to do it in pencil because you've got to do some erasing. Okay? I'm going to do some of it in pencil and some of it in dark because I know which ones, I kind of know in advance which ones to do. Okay? You might not know that yet. Okay, so we're going to do all the thing over, but I'm going to put my electron dots in pencil. All right? So then we want to look back up here in our Lewis dot formula and find the sets of electrons that are shared. Okay? And replace those sets that are shared with the atomic symbol they go along with. Okay? So the double bond right here, we know we got to put an oxygen there, right? Mm-hmm. Okay, so we're going to erase then that pair and put the nitrogen there. I'm sorry, not the nitrogen, the oxygen there, okay? All right, and then the other 2 sets of electrons, one's a lone pair and one's a shared pair. It doesn't really matter on a trigonal planar which one of those 2 you put it on. Okay. So you can choose either one you want to put it on, okay? Just to keep up with what you're doing, I'm going to put it down here too. Okay? Now sometimes where you put them makes it easier to see the result, but there are 2 shapes where it matters where the lone pairs remain.